All right, I think let's go ahead and get started. Morning, everyone. Let me quickly introduce myself. I am a distinguished engineer and system architect of Ethernet controller at Broadcom, and I have been also doing my second duty at DMTF for a long time as a VP of Technology and Technical Committee Chair. To give you a little bit background on this talk, we have several other talks after this where we'll go in details, but I felt that OCP and DMTF relationship originally started sometime around 2011, 2012. I think those who remember remote machine management specification effort, I was one of the author of that with Grant Richards and other. So that time, everything needs to be out pretty soon. It was all IPMI based, but that's when all the discussion started saying, we want to go down the path of DMTF standards, both not only external facing, but also internal facing. So from there, there has been significant development in hardware management group, as well as the server mass group, as well as OCP NIC 3.0 effort. So there are several of those activities within OCP where DMTF standards are being leveraged, and OCP and DMTF is working very closely together. So that's why I took this opportunity to give you guys some overview of DMTF and how things relate to OCP, specifically those areas where there's a lot of joint collaboration going on. And I'll follow up with, there are a couple of talks we have from Jeff Order and John Liang on Redfish specifically. There are other talks around multi-host NIC management and OCP NIC 3.0, where also you will see discussion around what DMTF standards are being leveraged. So with that, what I'll do is maybe initially I'll spend a few minutes just to introduce DMTF, and then we'll go into very specific OCP and DMTF relationship. So a little bit of background on Distributed Management Task Force. Many times I get our execs saying DTMF. DMTF is very hard to, so I want to spell it out, what it stands for. Its roots go back all the way to like desktop management. Believe it or not, it's more than 2 decades plus. So it started with that. There are a number of standards around desktop management, including one of the most successful one, SM BIOS, which you see in every platform today. There are billions of platforms shipped with that. So that was in 90s. And then in 2000, that's where the server management activities came into picture. Smash and Dash, virtualization management, those are the standards that DMTF focused on, so it built the base. And then in last decade or last 8 years, focus has been on Redfish, scale out, cloud infrastructure management, as well as what started in the between 2005 and 2008, there were first set of standards that came out for the internal facing interfaces. So those who have heard words like NCSI, MCTP, PLDM, those things are foreign to you. Hopefully after this talk, it won't be as foreign. But that effort has continued for more than a decade now, and we are seeing significantly wider adoption of it. Interestingly, these internal facing standards, they were first adopted by desktop and mobile platforms, and now server platforms are adopting. So that was kind of interesting for me to see. Maybe it depends on where the initial work started with. But right now, if you look across the industry, those standards are now adopted widely in server platforms, as well as they were already in desktop and mobile platforms. So I'll go into some of those low-level internal facing interfaces and standards that DMTF has developed. So in this talk, we'll focus mainly on the Redfish and those internal facing. So between that, you will see how the external facing and internal facing interfaces and protocol, they cover the entire stack of platform management. So if you look at the technologies that DMTF focuses on from the stack standpoint, all the way from the top is all the infrastructure that we see in data center, the cloud infrastructure. Below there, you may or may not have virtualization layer. And then you go down to the next level, the actual physical hardware, where you have compute, network, and storage. And within those, you also have between components of server. Okay, I think I was. You're hearing, right? Okay. So within those server components between BMC and NIC, BMC and storage controller. So if you really walk down the stack, if you go from top to bottom, all the way from high level, your northbound cloud management infrastructure, to what happens within the box, those all need to work together in order for you to really have a standards-based approach. And an example would be is somebody who is monitoring a specific server and trying to monitor its temperature continuously. There may be a REST API here, which may be exposing that server through that. And then within server, the BMC might be getting over SM bus information about what's the current temperature based on the temperature sensors you have in. And that will be converted from that kind of low-level information to some high-level data model, which may be exposed all the way to the top layer. So you can see it's a fairly complex stack where at every layer you have a model interface and then protocol that maps to underlying low-level model. And in order to have this useful, you need to have information flowing all the way from the top to bottom. So that has been focus of DMTF, and that's one of the reasons why we have been successful with the standards. We have different work groups working on different aspects of this layered protocol stack, and they all work together for specific use cases, solving the use cases, and that's how things fit together. And behind that, we have a set of tools. This is where all the data models, whether it's Redfish style or the common information model, object-oriented, or the low-level data model like platform-level data model, they all come into picture. And as you can see, pretty much that covers all the platform you can think of on the cloud or infrastructure side, your compute, network, and storage, as well as your client side, which is your desktop and mobile platforms. So this should give you an overview of what DMTF Technologies, these are all existing technologies, and we continue to enhance this. Other two things I want to stress is we have been very active recently in making sure not only the standards that are published are DMTF standards, but they are internationally known and as well as national standards. So regarding that, we have several of our standards, they are now ISO standards. And that does help from the standpoint of its applicability across the globe. Other thing we started almost 5 years ago was, even though we are a standards body, we wanted to influence a lot of implementation in the open source. So we increased our efforts significantly in the last 5 years, where not only there were open source projects that we sponsored or supported or encouraged, people working in both standards body, taking it back to those open source projects, doing the implementation, bringing the feedback. In addition to that, with the Redfish development, we have developed our own open source tools, validators, checkers that are out on the GitHub. So DMTF this way is now involved both ways in developing open source projects as well as sponsoring or contributing standards-based implementation to open source projects. So these are a couple of key items to keep in mind how the organization has morphed. So with that, I'm going to take a pause here. That was just a quick intro to those who are not familiar with Distributed Management Task Force. This gives you an overview of what DMTF does. For the rest of the talk, I'll focus on the OCP platforms management and where DMTF standards apply. So let's look at OCP. This is my view of, you look at your OCP server, whether we are talking about compute, storage, but then you have always some hardware management aspect of that server, and that's where this whole hardware management group works on BMC and other implementation. Now, there are also devices and device interfaces that are being standardized for things like OCP NIC. So BMC communication with that NIC is also based on standard interface. So if you look at that OCP layer all the way from the server, where somebody is trying to manage that server, that's where the Redfish kind of API or client interface comes into picture. Below that, once you are inside the BMC or management subsystem, there are standard interfaces that are already been used by OCP MAS group today, NCSI or RMII. And what it is, I'll go in a little bit detailed here. But it's basically a sideband interface which allows a BMC to share a NIC for both host and management traffic. In addition to that, it allows BMC to get standard inventory monitoring and control of the NIC. So these are the internal facing interfaces which are not visible to the client who is interfacing. But for example, if you are reporting link status to the client for a given NIC or on that server, internally BMC will get it over NCSI style interface. Then it will present it to the client in a model which is based on Redfish style REST defined model. So that's how everything fits together. And these are the key areas where Redfish and the external facing standards that are developed by DMTF and the internal facing interfaces and protocols fit together for OCP platforms. And that's primarily been our focus with OCP, working with different groups, hardware management and MES and NIC subgroups. So primarily, I'll go over, quickly give an overview of each of these standard. And there are two talks, as I said. Jeff and John will go in more details on Redfish OCP profiles. And there are other talks around OCP NIC 3.0 and NIC management, where NCSI, MCTP, PLDM will be discussed in more detail. And again, here is the spelling out of those acronyms. And we'll go over what they're really designed for. So let's first start with the external facing piece. So Redfish, very simply, you can think about this is basically your interface, HTTPS, JSON format base, and the data model you define. So it's a data model and protocol interface. That's what Redfish is about. It started in 2014, so it's been out there for a while, and we can continue to enhance this interface with more and more use cases. And as you know, initially it started with the compute type of model, but then the storage came into picture, and then we started getting other standard organization, other use cases into it. So now it has expanded to multiple areas beyond just the compute. It covers network, it covers storage, it covers power and cooling domain. It also covers telco kind of style. So this is where the profiles come into picture, because DMTF has defined this data model interface, but for specific domain, you need a common set, which we were talking about in the previous talk. So that's what the OCP profile is about, that you define using that described model of DMTF. You are now prescribing specific objects and properties that you expect an implementation to have. So if you really look at it, you start with the common base, which is common across all the platforms, and then you can specialize for specific platform additional objects and property. So that's what effectively a profile is about. You will hear a lot about these profiles in next hour or so. So I won't go into details. I think Jeff and John will cover that. So that's the external facing piece. internal facing, which is where I want to spend some more time. If you really look at platform management subsystem, you have the management controller, and of course, those who are working on BMC, management controller is looking like a heart to you in the system, so that's why it's in center. But there's ongoing communication between the BIOS and platform firmware components. There are sensor devices, intelligent management devices, network controller, as well as you may have a secondary management controller. So all of this is part of your platform management subsystem. So more than a decade ago, we looked at this as a problem, saying this is the area where having a common low-level transport and a low-level data model that you can expand on really helps. So that's how the whole platform management communication group came into picture. And primary focus here was on the transport and the low-level data model, which applies to all of this. And I'll touch on all three standards here. So this was the group within DMTF which works on those standards. It's been in existence for 13 years. And as I said, first adoption of this came on the desktop and mobile platform side. And now we are seeing servers also adopting. And on server side, it has been interesting. The NCSI, I remember, if Bob is not here, but Bob and I, 1.0 version, when we published that in 2007, NCSI has been adopted in most of the server platform. But the MCTP PLDM adoption has been slow. But now, with the use cases like firmware update, BIOS control and configuration, there are more and more of those use cases are driving adoption of that. So that has been the history of how these standards have been developed and how they have been adopted. So primarily, it's all about inside-the-box communication. That's the focus of that group. So just like any stack, I like to look at this is the low-level stack. Effectively, you can think about MCTP is your transport layer, equivalent to what you can think about TCP/IP, but it's a much lightweight. There are multiple physical medium that are supported by MCTP. That's how it's common across multiple physical medium you will find in the platform. So you do have SM bus. There are legacy interfaces like KCS and serial. Also new interface like PCI VDM, use of vendor-defined message. So by having all those bindings, MCTP provides that physical layer independence. And this way, your upper layer, this is where your request response style communication, control and discovery protocols, they can all sit on top of MCTP without really worrying about any of the physical layer dependence on that. So this is how currently existing stack we have. We continue to enhance the transport layer as well as upper layer. Recently, we added NVMe over TCP, so you can see NVMe work group. We work together with NVMe or MCTP support. That's an example of it. We are working on Redfish device enablement using PLDM. So that allows you to have Redfish style model that you can communicate over this low-level transports between the devices within the system. So that's the PMCI protocol stack that we have been developing since last, as I said, 13 years. So let me go over the key components here. NCSI, what this is NCSI allows a NIC to be shared for the host traffic and management traffic. And it's a shared NIC model. And what it has is it has the pass-through communication that allows the management traffic to be passed through from NIC to and from the network. as well as in order to control that kind of pass-through communication, also to get to NIC inventory monitoring and control aspect, you need to have command response style protocol. So that's the second piece of it. NCSI has pass-through communication, NCSI command responses, which goes only between BMC to NIC. Pass-through goes all the way from BMC to the network. And then NIC needs to also have a model to inform the BMC if there is some change in its state. So for example, link went down. So that's where asynchronous event communication model is built into the NCSI model. So that's the NCSI communication model. It started with RMII, which is 100 megabit interface with the hardware arbitration defined for that to support multi-drop implementation. So that was the original one where physical level was RMII based, and then Ethernet is the media level. Recently, we also took NCSI and mapped it over MCTP. So that allows you to now have NCSI communication over MCTP SM bus or PCI VDM. Reason why this is important is not all implementations, especially PCI NIC implementations, do not have RMII connectivity today. So by having this NCSI or MCTP mapping, you can cover your OCP MAS, LOM implementation as well as PCI NIC implementation with one set of NCSI command that you can support over multiple transports. So that's this is primarily the sideband interface in both MAS 2.0 and OCP NIC 3.0. MCTP, this is basically, think about this for inside the box communication. This is the base transport. It is medium independent. I said that's why there are multiple medium binding that are defined by the standard. It also supports carrying multiple traffic type on top of that. So from that standpoint, you can think about over TCP, you can run HTTP, FTP, others. So this allows you to have MCTP as a transport, but you can carry PLDM, NCSI control, NVMe, all those different traffic on the same transport. So that's built into the transport. And of course, idea here is this is inside the box, so we want to keep it simple so that low footprint implementation can support it, as well as it doesn't require significant complexity in the firmware. So very simple fragmentation and reassembly capability is built into the protocol. And it does have also logical endpoint ID, similar to IP address kind of addressing scheme, but much simpler. But this basically allows MCTP to have logical addresses that you can use within a smaller MCTP network without really worrying about specific physical addresses. So it supports both model. You can use physical addresses as well as logical addresses. So that's MCTP protocol. And PLDM is basically a model, data model. And this is not like your traditional data model you see in REST style or object-oriented. This is more low-level, bit-oriented data model where you define a bunch of request-response style transfer. Within that, you standardize how data structures are transferred, whether that being an SM BIOS table or BIOS table or firmware images. So that's where the PLDM comes into picture. And it is transport independent, so it can run over RMII or it can run over MCTP. Primarily, PLDM or MCTP has been used. And the way the model is defined is there is a base PLDM which allows you to do basic discovery of what PLDM implementations are supported by a given implementation. So for example, somebody will only support PLDM firmware update. So you want to discover that. So that discovery is built into it. And there are rest of number of standards which are listed here, which defines different aspects of PLDM. So there is one for SMBIOS data transfer, another one for BIOS control and configuration. For sensor-based monitoring and control, there's a separate specification, and then firmware update, there's a separate specification. Also, the through data transfer is another one. And as I said, we are working on Redfish device enablement using PLDM. So that pretty much summarizes the NCSI, MCTP, and PLDM standards. So hopefully with that, I gave you a quick overview of DMTF, Redfish as the external facing interface that is applicable to hardware management group, as well as for the internal communication, the NCSI, MCTP, and PLDM spec. And as you can see, we're very open. OCP and DMTF has been working together for quite some time now. And we are seeing a lot of this efforts are coming to fruition, whether through OCP Redfish profiles or in the MAS 2.0 or OCP NIC 3.0 standard, different management use cases. So with that, I'll stop here and take any questions.
There's also a mic over there.
Hemal, can you talk a little bit about what Redfish device enablement might mean to OCP NIC?
Okay, good question. So what Redfish device enablement will mean to an OCP NIC is, in addition to this low-level data model and interfaces you support, you can offload some of the BMC function in terms of maintaining of Redfish schema, which is specific to that NIC, without worrying about actual external communication. So this way you can have a more kind of distributed data model. And so think about Redfish objects are now transferred over low-level transport. But NIC doesn't have to worry about the HTTPS and all the stack that's being maintained by BMC. So this allows BMC to be a pass-through, where it can pass a bunch of Redfish operation directly to a NIC, and NIC can support those over PLDM. And that's, we just released work in progress. So those who are interested in it, you can go and look at Redfish device enablement work in progress, provide us some feedback. Yeah, go ahead.
Yeah, I've seen the document about a couple of months being floating around about OCP demanding, forming a standard that any design submission will need Redfish to accompanying it. Is there a, and I didn't see any announcement in OCP in this OCP summit. Is this still going on? Are you aware of it? Or?
Go ahead.
Sorry, do you mean that?
There was like if a vendor submit a let's say a networking device for submitting into OCP, then there was a consideration about that they need to submit it together with a Redfish implementation to accompany that design.
Well, for sure, at some point in the future, we'll want Redfish to be a mandatory part of the spec.
Yeah, that's what I was talking about.
But today, that's not the case.
It's not there.
No.
Today,
So
yeah,
this
that's
was
why.
not.
No. We're still working on how to actually go about doing that.
Okay, thank you.
Yeah, and I think you'll get more details on this in next 2 talks if you want to stick around on Redfish profiles.
Okay, thank you.
All right, thanks everyone.